Good morning, all. Last class we discussed about indexes, primary index as well as clustering index. Both were non-dense index. In that sense, not all record key values are having entries in the index file. Only those uh, records or anchor records whose key values will appear in the index file. Now we'll be discussing another index which is known as secondary index. A secondary index provides a secondary means of accessing a file for which some primary index already exists. For example, consider an employee file. We have a primary index on employee number attribute. Employee number as the key value. Now you want one more index, so that we want to access the data file in a faster way with another attribute. For example, employee name. If the records are sorted based on employee number, based on the other field, employee name field, that file may not be in sorted order. But in that case, if you want to search in that data file to get a name or name based search, then you have to perform a linear search. If there is 3000 entries, then on an average 1500 records needs to be, or 3000 blocks, then 1500 blocks needs to be accessed to perform the linear search on an average. Whereas if you have a secondary index on the other field, it can be done in a faster way. For secondary index provides a secondary means of accessing a file for which some primary index already exists. That means you can search with the primary index using the index. With the secondary index, you can search using second field, another key field. Secondary index may be on a field which is a candidate key and has a unique value in every record, or a non key with duplicate values. It can be a candidate key or a non key, no problem. Index is ordered. Again, here also the secondary index file that we created will be an ordered file with the two fields, ki and pi. K is key and pi is the pointer to the corresponding record, not the block pointer or record point. You can say it's a record point. Even though a block will be accessed, it should be to the specified record. The first field is indexing field, second field is either a block pointer or a record pointer. There can be many secondary index for a file. You can have a primary index as well as a number of secondary index on different fields if required. It includes one entry for each record in the data file. Hence it is a dense index, not a sparse one. That is, the index here, for every record in the data file, there should be a corresponding entry in the index file. That is why it is a dense index, not a sparse one, like the primary or the clustering index. Thus, secondary index needs more storage space and search time than primary index, definitely, because for every entry in the every record, there should be an entry in the index file. But improvement in search time for arbitrary record is much greater. That is better than performing a linear search. We'll see example. This is an example. Here this is the data file and this is the index file. You see this data file, the first field which is not shown here, the data file is sorted based on that one. The second field or the secondary indexing field with which the file is not at all sorted. That is what the issue here. Here previous primary index case, the file was sorted, therefore the indexing field based on indexing field, it will be in increasing order. Here the file is sorted on another field, you are creating index on yet another field. For example, this is employee number, this is employee name, or any other attribute. Here, based on this attribute value, these records are not at all sorted. That is why a pointer is required to each of the blocks or each of the records. But the index is in sorted order. That is the sorted order of this indexing field. Okay, this is in sorted order, and first field, this is number 1. Number 1, where is number 1 is in this block. Therefore, this record pointer or the block pointer should be pointing to this particular block. Number 2, key value. Key value means the secondary indexing key value. This is the index entry 2. Index entry 2 is in third block. Therefore, the pointer should be this. Therefore, all the records, for each record, one entry should be there in this one. Here there are 24 entries corresponding to the 24 records of the data file. That is what the secondary index. Now we will see number of block access required. Example, given the following data file, employee, name, SSN, address, job, etc. Suppose that record size is 100 bytes as in the previous case. Block size is 1024 bytes, 1024 bytes, and number of records 30,000 records. Then we get blocking factor. You can have 10 records per block. Number of file blocks is 3000 again, because you have 30,000 records divided by 10, 3000 blocks. 3000 blocks are required. For an index on SSN field, assume that the field size is 9 bytes and record size is 6 bytes, then index entry is 15 bytes. Here assume this is the field on which you are creating a secondary index. SSN is a field based on which you are going to create a secondary index. Already the file is having a primary index, okay, or what it may be. VSSN, the bytes required for the data key value is 9 bytes and pointer is 6 bytes. Therefore, index entry in the index file, each entry or each record of the index file size is VSSN plus VPR, that is 9 plus 6, 15 bytes. Now the index blocking factor is 1024 is a block size divided by 15 is the size of each record. Now you got 68. Total number of index entries is number of records in the data file, that is 30,000, because in the previous case primary index, what was the difference was you want to create index only for 3000 blocks. Now you have to create index for 30,000 records. That's what the difference, because the records are not in the sorted order. You are creating a secondary index on another field which is not at all sorted. So you have to create index entries for 30,000. Now the total number of entries required is Ri divided by number of records Ri, 30,000 divided by 68. 68 is the number of index entries possible in a block. Therefore, the index file, secondary index file, should have 442 blocks of size 1024. That many number of blocks. Therefore, to access the index file or to perform a binary search on this index file, the total number of block access required is log to the base of block number, that is log to the base of 442, 9 block access, that you will get the corresponding the address only, record the block point or record pointer only. One more access to one more to search a record using the index, we need one more block access. Therefore, total 9 plus 1, 10 blocks. Total number of block access required in the case of secondary index is 10 block. But this is because our records are not sorted on the indexing field, the secondary indexing field, the only other option is linear search. That is why on an average you have to perform 1500 because the data is organized in 3000 blocks. You have to perform a linear search. On an average it will take 1500 block access. When compared to that, this one is much faster. Much faster means here you need only 9 plus 1 10 block access. Okay, so for this is what the secondary index. So far we have seen primary index. There the case is you are creating index entries only for the beginning or anchor record, only those data records that comes in the, that are coming as the first record of each block. Whereas in the case of clustering index, you are creating index entries for every unique entry. Clustering index, the case is you can have a known key field, that is there can be duplicates also. Have key field but just having a duplicate also. Now what is next is multi-level index. Here you have seen a secondary index, primary index as well as one. Now if you have a multi-level index, what do you mean by multi-level index? A binary search on an index file with BI blocks require log2 to BI number of block accesses. Now if multi-level access reduce index search time by log FO to BI, where FO is fan out of multi-level index. Multi-level index, in that sense you can have multiple levels of index. Such time is smaller if FO is greater than 2. Because of a single level index is an ordered file, what's the idea behind this is, in the case of multi-level index, the idea here is we can create a primary index to the index itself. Because you have an index file, the index file is an ordered file. For this ordered file you can create one more index. To that one we can create one more index, like that until you have a single block which contain the important keys. We'll see with example, then it will be more clear. Multi-level index, not as this is compared to single level index. Single level index you have only one index file, one index level. In the case of multi-level index, the index file itself is having multiple levels. In this case, the original index file is called the first level index, and index to the index is called the second level index. You can have third level index, and you can repeat this process creating third, fourth and top level until all entries of the top level fit in one disk block. Therefore, what's the idea here is you will be creating index files for the index files until you get an index file with a single block. Therefore, you will be having a single block. From that single block you can go to next level. From that next level you can go to the next level until you reach the required record. Okay, this is an example. Here you can see that here this is our data file. Each block having 2 records only. Number of blocks, each block are having 2 records only. You'll be creating an index. Index entry will be for records that comes in the first record. That is, this is the anchor record, correspondingly 2 will come. This is 8 anchor record that will be coming, this will be pointing to, and the index can have 4 records per block. Data file to index file 4 records per block. Now it is 15 is the next, 24 is the next. Therefore this is the index blocks, first level index blocks. You can see that 2, 8, 15, 24, 35, this search key value is in increasing order, or the index file itself is an ordered file. You can create one more level of index. What will be coming here? 2 is the anchor record, 2 will be coming, then 35 will be the next one, 35 will be coming, then 55 will be the next one, 50 will be coming. Therefore this is the second level in top level index. This is can be accommodated in a single block. For first level you will coming and this one, for example you want to search for a record 36. 36 means here 2, it is 35, therefore we will be going by this link. Here one more index, that it contains 35. 35 is next, or key is 36, which will be while tracking this record, this 35 record, you can see this is 36 record. Therefore the number of access here is 1 plus 1 plus 1, 3 only. Number of block access required, that is previously by creating one more level of one more means more than one level of indexes, you can reduce the number of block accesses. Okay, now we will see with an example how this will be. Number of block access of multi-level index. Consider this case. This case is our previous secondary index creation. For this secondary index, we are going to create a multi-level index. Here in this case, consider the dense index of previous example. Record size is 100 byte, block size is 1024 bytes, number of 1024 bytes, and the record is, total number of record is 30,000 records. For an index in SSN field, assume this is 9 plus 0.6, therefore total is 15. The index entry is 15 bytes. 15 bytes in one block means 1024 divided by 1568. That these are all we have seen in the previous example itself. Then number of index block is 30,000, because this is a secondary index. Edge will be having 30,000 divided by 68, 442 blocks. And the number of block access required is 9 plus 1 log to the base 442 is 9, which plus 1 for the record access, that gives 10 is the number of block access required. Suppose that a dense for this, suppose that the dense index in the previous example is converted into a multi-level index. Number of first level index block is B1 is 442. For this 442 blocks, you will be creating an index. And how many entries in a block? Index entries in a block 68. For 442 divided by 68, that upper end, that you will be 7 blocks. For next level, the first level index is having 442 blocks. Next level index, or index for the index, will be having 7 blocks, and the 7 blocks should be again one more, that is 7 divided by 68, that is one more block. Therefore the third level index is required. Third level index 1 block, second level index it is having 7 block, and the first level index which is having 442 blocks. This is what the index. To access the record by searching the multi-level index, we must access one block at each level plus one block from the data file. Total number is 3 plus 1, 4 block access. For total number of block access required is 4 block access when we created a multi-level index, that is for the secondary index. For the secondary index, we have created a multi-level index so that the number of block access is reduced from 10 to 4 block accesses. So for the multi-level index with R1 first level entries will be approximately, will take T is equal to log upper limit of log F4 to the R1 levels. This is the number of levels. In the previous case, R1 was 442 blocks. Then still faced with the problem of dealing with insertion and deletions because of all indexes are physically ordered files. This index file, multi-level index, are ordered file. It is insertion and deletion that will be creating issues. Therefore, a better technique for which a dynamic management of indexing, a multi-level index itself, that will be discussed in the next lecture, that is B trees and B plus trees, or multi-way search trees, that will be discussed in next lecture. Thank you.